Welcome to How to Be Bachelor of Engineering. This tutorial will discuss a parallel combination of resistor, R, inductor, L, and capacitor, C in electrical AC system. Previous lessons, we learned: what is pure resistor? A pure resistor, the current and voltage are always in phase. What is a pure inductor? A pure inductor, the current always lags the voltage by 90 degrees. It is receiving the energy and returning back energy to the supply source. What is a pure capacitor? A pure capacitor, the current always lead voltage by 90 degrees. A pure capacitor is returning stored electrical energy from the supply source. Does not perform any real work. Let us proceed our lesson with parallel RLC circuits. The resistor value is 10 ohms, the inductor is 0.10 Henry, and a capacitor is 100 microfarad. The result of impedance is 3.29 ohms, and the result of current is 68.87 ampere. The apparent power is 16.07 kV-ampere. The result of reactive power is 15.17 kV-ampere reactive. The power factor of 0.33 lagging. Change the resistor value to 100 ohms, the inductor value to 0.10 Henry, and the capacitor value to 200 microfarad. Observe the result of calculation. The result of impedance is increased to 30.69 ohms, and the result of current is reduced to 749 ampere. The apparent power is 1.72 kV-ampere. The result of reactive power is 1.63 kV-ampere reactive. The power factor of 0.30 lagging. Update the value of resistor to 10 ohms, and the capacitor to 10 microfarad only. Please observe and understand the result. Again, change the value of resistor to 20 ohms, the value of inductor to 0.05 Henry, and the capacitor to 150 microfarad only. Again, change the value of resistor to 50 ohms, the value of inductor to 0.10 Henry, and the capacitor to 20 microfarad only. Change the value of resistor to 12 ohms, the value of inductor to 0.15 Henry, and the capacitor to 100 microfarad only. Enter the final value of resistor to 20 ohms, the value of inductor to 0.20 Henry, and the capacitor to 200 microfarad only. The result of impedance is 14.58 ohms, and the result of current is 15.78 ampere. The apparent power is 3.62 kV-ampere. The result of reactive power is 2.48 kV-ampere reactive. The power factor of 0.73 leading. The result of real power is 2.64 kilowatt. Increase the value of resistor to 200 ohms only, and observe the result. As you notice, the result of impedance increased to 21.19 ohms, and the result of current decreased to 10.85 ampere. The apparent power is 2.49 kV-ampere. The result of reactive power is 2.48 kV-ampere reactive. The power factor of 0.1 leading. The real power is 264.40 watts. Double the value of resistor from 200 ohms to 400 ohms. Please observe the result if you increase the load resistance. What will happen to the circuits? Let's try this method. If we slowly increasing the value of resistor from 20 ohms to 400 ohms. Please observe the graphical waveforms. As you observed in the waveforms, the result of impedance increasing and the load current is decreasing. The power factor is reduced from 0.73 to 0.05. Means, the current and voltage are going out of phase each other. Let's try this, slowly decreasing the resistance value from 20 ohms to 2 ohms. You look at the waveforms, how it will change the value. Now, we try to change the value of inductor only, to 0.4 Henry. Observe the change in the circuit. Again, change the value of inductor only, to 1 Henry. The result of impedance decreased to 12.84 ohms, and the result of current slightly increased to 17.90 ampere. The apparent power increased to 4.11 kV-ampere. The result of reactive power is 3.15 kV-ampere reactive. The power factor of 0.64 leading. The real power is 2.640 kilowatts. Let's do it again. If we slowly increasing the value of inductor from 0.20 Henry to 1 Henry. Please observe the graphical waveforms. As you notice, from the calculation result, the impedance value is increasing, while the current is decreasing. Both the apparent power and reactive power is also decreasing. The power factor is also reducing. It means, the current and voltage are going out of phase each other. The result of real power is slightly remain as 2.645 kilowatt. If slowly reduce the inductance from 0.20 Henry to 0.02 Henry. Check the result. Let's proceed to change the value of capacitor to 400 microfarad. Try also slowly increase the value of capacitance from 200 microfarad to 800 microfarad. You can see the actual calculation. The value of impedance is decreasing, and the result of current is increasing. Both the apparent power and reactive power are increasing. The power factor is reducing from 0.73 to 0.20. Means, the voltage and current are going out of phase each other. That is our tutorial. Thank you for watching. Please don't forget to subscribe. See you again.